Happy Thursday. As was mentioned, I'm not going to worry too much about we missed a day. Just going to push all the lessons back by one meeting. And so we're supposed to do partial fractions on Tuesday, so we'll just do it right now. Partial fraction decomposition. This method is now going to allow us to take the antiderivative of a quotient. And so you can think of it as the analog of the quotient rule. So the general idea of method of partial fractions is first, you want to make sure that your fraction is proper. What does it mean for a fraction, for a rational function to be proper? Who remembers?
I believe proper fractions are ones that are less than 1.
Well, that's if it's a fraction, right? So yes, but what about if it's a rational function? What does it mean for rational to be proper?
The denominator is a higher degree of the numerator.
Right, degree of the numerator is less than the degree of the denominator. So that's your first step. Well, this is improper, so we have to make it proper. There are two ways of making it proper. First is synthetic division, which only works if the denominator is linear. This one is not, which means we have to go with polynomial long division. Does that sound familiar from algebra? It should. What do we need to multiply x cubed by to get x to the fourth? So do that actual product. And then you subtract. Oh, look at that. That's going to be nice. So what comes down is just negative x minus 1. That has a smaller degree. So that's our remainder. Right, that means this rational function is written as x plus the remainder. I'm going to factor out the minus. We're finding the antiderivative of x. That's simple enough. What about x plus 1 over x cubed minus x squared? This is where we're going to have to write it in its partial fraction decomposition. First thing we want to do is completely factor the denominator. The next step depends on what the denominator looks like. All of our factors are linear. X is linear. X minus 1 is linear. The fact that it's x squared just means that it's repeated. I factored a negative out.
So if you didn't factor it out, it would be x plus x minus 1 over x cubed.
Negative x minus 1. Right, yeah. Both give you the same thing. It's just I don't like negatives, so I factor it out. But it doesn't matter. Right, what this tells us is our partial fraction decomposition is going to look like a over x plus b over x squared. So those two terms are from the x squared factor. And then that final term comes from the x minus 1 factor. A, B, and C are some constants that we're going to have to find. Well, how do we find them? That's easy enough. Clear out the denominator. So multiply the entire equation by x squared times x minus 1. We'll get x plus 1 is equal to ax times x minus 1 plus b times x minus 1 plus c times x squared. The way that I typically proceed is I now look at coefficient comparison. So group all of the x squared terms together. Right, we're going to have an a, right? Plus c is our coefficient for x squareds. Now look at the x. We have a negative a plus b, don't we? And then our constant, we just have, it should be a negative b. The idea behind coefficient comparison, polynomials are equal if and only if corresponding terms have identical coefficients. Right? So the coefficient of x squared on the left has to equal the coefficient of x squared on the right. Coefficient of x on the left has to equal coefficient of x on the right. The constant on the left has to equal the constant on the right. On the right-hand side, coefficient of x squared is a plus c. What is it on the left-hand side? So a plus c has to equal 0. On the right-hand side, coefficient of x is negative a plus b. What is it on the left? So negative a plus b has to be 1. The constant on the right is negative b. What is it on the left? So negative b has to be 1. This gives you a system of 3 equations and 3 unknowns. And you should have studied that in algebra as well, how to solve that system. It's called the method of elimination. This system is actually very simple to solve. Right away, we know B has to be -1. If B is -1, then what does A have to be? -2, right? Because you have that negative in front of the A.
Isn't that negative?
That would become 2.
Yeah.
Right? Well, now we know A is -2, so what does C have to be? Like I said, that was a fairly simple system to solve. Coefficient comparison, right? So coefficient of x squared on the right-hand side was that A plus C, right? Look on the left-hand side, which is x plus 1. What is the coefficient of x squared? 0, so it has to be 0. Because your coefficients have to be the same. And it's the same argument for the others. We now have our A, our B, and our C. I'm not rewriting the integral. I'm using instructor's prerogative with technology. Doesn't want to let me do it. Uh-oh, there's the mouse. What's going on? Technology, why do you do this to me? Okay, well, that's not quite what I wanted it to do. So let's try that again. But you still have that x floating around, right? Minus, but now that fraction comes into play. That fraction can be written as -2 over x minus 1 over x squared plus 2 over x minus 1. Distribute the minus through. Now we can finally do calculus. Antiderivative of x. Antiderivative of 2 over x.
Two times the natural log of absolute value of x.
Antiderivative of 1 over x squared. Antiderivative of 2 over x minus 1.
Two times the natural log of the absolute value of x minus 1.
And add your constant. There's our antiderivative. By the way, we can simplify this.
Thinking of applying the two natural law, but I was thinking of the projects too.
We could also just square what we're taking the natural log of to get rid of that too. Nah, I don't really see any benefit to that, so I'm just gonna leave it like that. Yeah, and the actual calculus was easy. It was getting up to that part. It's a bit of a pain. Ah, they were nice to us. They gave us the denominator already factored. That makes our job a little bit easier. Right? First step. Check that it's proper. Is this rational function proper? It is, which means we do not have to do long division, which is nice. Now we just jump right into writing its partial fraction decomposition. All right, so just go factor by factor. X plus 2. It's linear, it's not repeated. So that factor contributes to the decomposition, a over x plus 2. X plus 3, linear, not repeated. That contributes b over x plus 3. Now we have to solve for a and b. All right, so multiply by x plus 2 times x plus 3. Here's so I can take a shortcut. Both factors are linear. Both factors are not repeated. Instead of doing coefficient comparison, I can do another technique. This equality has to be true for every single value of x. That means it has to be true if x is -2. That means a is -2.
Same thing, but just want to see.
For the sake of time, I'm not going to do it for this problem. Well, there's plenty of other problems where I'm going to be doing it. And I would recommend if you have something like this, this is the shorter method. Right, half of taking a test is time management, sadly. It also has to be true if x is -3. I'm just trying to zero out
Oh, yeah.
the other term. That means b has to be 3. Right, that means that x over x plus 2 times x plus 3 is negative 2 over x plus 2 plus 3 over x plus 3.
Explain that,
What do you mean?
the last part you just said.
So we saw for A and B, right? So I'm just plugging them back in to up here. Because remember, you have to have a common denominator when you add fractions. So what we're doing is the reverse of that, right? Instead of combining everything into a single fraction, we're decomposing the fraction into separate fractions to make it easier to find the antiderivative. If you combine these two fractions, you will get x over x plus 2 times x plus 3. Right, and the idea comes from, right, common denominator. So one denominator would be x plus 2, one would be x plus 3. To keep both fractions proper, degree of the numerator has to be no more than one less than the denominator, right? So that's why it's just a and b. When we get to quadratics, we'll see that the numerator becomes linear. All these antiderivatives are fairly simple. And there's our antiderivative. Could combine them, but different coefficients, so I'm just going to leave them. Another one where they gave the denominator already factored. That's so nice of them. Is this proper? Yes. Numerator has degree 2, denominator has degree 3. So 3 linear factors. First is x. It's not repeated. Gives us a over x. Second is x plus 2. It's not repeated. That contributes b over x plus 2. And then x minus 1 is not repeated. That'll contribute c over x minus 1. All right, solve for a, b, and c. Clear out your fraction. The rest of these will have to be coefficient comparisons, so I'm just going to use the simple method again for this one. Both B and C have an X term, right? Let X be 0. That'll cancel out the B and the C, right? 0 squared plus 2 has to equal 2A. Means A has to be 1. Trying to solve for B, both A and C have X plus 2. So say X is -2. -2 squared is 4 plus 2 is 6. Would have to equal, what is that, -2 times -3. So 6B. Means B also has to be 1. Wait a minute. That should have been X minus 1 with the A, not X plus 1. We made that -2A, right? So it would have to be -1. Now solve for C, so let X be 1. That'll get rid of A and B. 3 has to equal 3C, which means C has to be 1. That is how our fraction decomposes. Or our rational function decomposes, I should say. Right. Antiderivative 1 over X, log absolute X. Right. Antiderivative 1 over X plus 2, log absolute of X plus 2. Log absolute of X minus 1. And let's go ahead and simplify this because they all have the same coefficient. And there is the antiderivative. This one's going to be a bit of a pain. Is this proper? Yes. And look at that, it's already factored for us too. First factor, x plus 2. That contributes a over x plus 2. Second factor is x minus 1 cubed. That will contribute b over x minus 1 plus c over x minus 1 squared plus d over x minus 1 cubed. And so you have to remember that if your linear factor is repeated, so it's being raised to a power, it contributes more than one term.
Are there any other things like that to remember?
Because quadratic's the same thing. If a quadratic factor repeats, it's the same argument. It just adds however many terms that the power is.
You're saying that if it was x minus 1 to the 4th.
There'd be a fourth term and that we'd have to add. We'd then have to add e over x minus 1 to the 4th, right? And the reason for that is, if you look at the right-hand side now, what is the LCD? What's the least common denominator of that? It's x plus 2 times x minus 1 cubed. Now, it's possible that B, C, B and C might be 0, right? We don't know. Now we're going to have to find out. So we're multiplying everything through by the denominator. Clearing out the denominator, that is what you're going to be left with. Notice why I can't use the same trick here. I can easily get rid of B, C, and D, right, by saying x is -2. I can also get rid of A, B, and C by saying x is 1. So we can easily solve for A and D, but not B and C, right, because they both disappear regardless. This is why I just typically stick with coefficient comparison for these types. It means we're in for some fun algebra. Expand out x minus 1 cubed. 2 of you know how to do this, because I taught this in Calc 1. You should be able to do this in 5 seconds. Now time's up. You make me sad. Let's take a shiv and put it in my heart. X cubed minus x squared plus x minus 1. Binomial theorem in Pascal's triangle.
What happened to the 3s that would normally be Can you pass it up?
Those actually should be threes, yes. I went too quickly. Minus 3x squared plus 3x minus 1. X minus 1 squared, we all know how to do that one. If I want to foil. Maybe not yet. So I was just expanding out the cubic and the quadratic. Now it really just boils down to how good are you at doing this in your head? Because if you're not comfortable, then you're going to have to foil. Distribute x plus 2 through. We're going to have an x cubed minus 2x squared plus 2x squared. That's nice. Then it looks like what? Plus x minus 4x minus 3x and then plus 2. X squared minus x minus 2. No, plus x. It's negative x plus 2x, yeah, plus x. Minus 2, and then just d times x plus 2. Right, now group together like terms. X cubed, a plus b. X squared, negative 3a plus c. X, we have 3a minus 3b plus c plus d. Constants, negative a plus 2b minus 2c plus 2d. And keep in mind that all of that is equal to x cubed plus 1. Right? Coefficient comparison. A plus B is going to have to be 1. Right? Negative 3a plus c is going to have to be 0. (3a minus 3b plus c plus d also has to be 0. Again, there's no x squared on the left. There's no x on the left. So those coefficients are 0. And then our constant, negative a plus 2b minus 2c plus 2d, that has to be 1. We have a system of 4 equations and 4 unknowns. This is not a nice system to solve by hand.
How'd you get what's at the top? Where'd that come from?
With my mouse. This?
Yeah, I have literally no idea where you, like, I looked away from the screen for 1 second and suddenly it was just all.
Welcome to math. Never look away from the screen. We just gathered like terms together. Right, so look for the coefficients of the x cubed. A plus b, right? Do the same thing for x squared. Negative 3a plus c. Same thing for the x. So we're just grouping together like terms. But think of them as numbers. Like I said. Hmm?
They're basically just saying a coefficient. It's not a variable.
Right.
It's a coefficient.
Right. A, B, C, and D are not variables. They're going to be constants.
Distribute those and then combine like terms.
Yes. That's exactly what we're doing. Yes. So I said just think of them like numbers. And that's exactly what we're doing. You could sit there and solve this by hand if you really wanted to. I'm not going to stop you. I, however, embrace #1 law of physics, which is the universe wants to be in its lowest energy state, meaning the universe is lazy. So am I. I'm going to use Mathematica to solve this system. You can also do this on the TI Inspire CX CAS. I don't know if the 89 can do it. Right. In the calculator menu, algebra, solve system of equations, solve system of linear equations. It's going to ask you for the number of variables. In this case, we have 4. It's going to ask you what the variables are. A, B, C, D, then just hit OK. And then you just fill in the equations. I am not going to do that because I'm going to do it in Mathematica. I'm just showing you how to do it on your calculator. Mathematica, I'm going to use the solve command.
Which link is this of the 4 that are on this page? You have to download it?
Yes, I'm using the desktop version.
Okay.
But if you use the online version, the command is the same.
Okay.
Now, normally solve is only used to solve a single equation. But if we put braces around it, we can give it a system of equations. Right now, it's just write out the first equation. Right now, be careful. I'm not doing a single equals for 1. I'm going to do a double equal. That is important. Mathematica, a single equals is saying I'm storing this specific value. A double equals is a test. No. Calculator, you can just do a single equals. Right. So A plus B equal 1 is saying, I'm saying A plus B is 1. A plus B double equals 1 is saying it's the set of all A and B so that their sum is 1. That's the difference. Separate each equation by a comma. Second equation was negative 3A plus C is equal to 0. Third equation was 3A minus 3B plus C plus D is equal to 0. And then finally, negative A plus 2B minus 2C plus 2D is equal to 1. There's our 4 equations. Now you have to let it know, what are we solving with respect to? So put in braces the 4 variables. Shift, enter, and there is the solution to the system. Got it? Or are you still typing it in?
Hold on.
Oh dear, that means you did something wrong. And then what you do is you quickly memorize this. You hide it and you just write down the solution. And when someone asks you how you knew that, you just go, it's obvious. That's how you impress your friends. I'm actually starting to wonder if it has a partial fraction decomposition command in itself, so I can skip all this. I'm not sure if it does. I'll have to look that up. Because if it does, that makes this a lot easier. You do, if you want full credit. This has just started.
That's the problem.
God, if you think this is bad, wait till Calc 3. Imagine doing this 3 times in one problem.
You subbed one problem 3 times last time. Just that was already too much.
Now that's for a single integral. Imagine doing it for a triple integral. That's Calc 3. Love Calc 3. Okay. First antiderivative is simple. Second is also simple. The third antiderivative. Derivative of x minus 1 is 1, so we can just treat it like 7/9 over x squared. So negative 7/9 times 1 over x, or negative 7 over 9 times x minus 1. Ooh, that's nice. An antiderivative of 1 over x minus 1 cubed is negative 1 over 2 times x minus 1 squared. Now multiply that by 2/3 and you have that part. There's our antiderivative. Yes. That's exactly what I'm going to do. I'm not dealing with 27th roots to 7th power or 20th. Yeah, screw that.
Can you repeat how you got the last two antiderivatives?
So think of 1 over x minus 1 squared. What's the derivative of x minus 1? Right, so you can just think of that as like 1 over x squared, right? Power rule. Add 1, divide by the same. So it'd be negative 1 over x minus 1. Right, because the power is minus 2. And it's the exact same argument for the x minus 1 cubed. Because that derivative is 1, you can just think of it as like x. And then the power is minus 3, so minus 1 over 2 times x minus 1 squared. And then you just multiply by that constant.
Do you mind if we write, instead of like putting x minus 1 in the denominator, we just put it in the numerator to a negative power? Like that's so simplified.
As a general rule of thumb with method of partial fractions, you don't want negative exponents. Because the rule of thumb is always to write your answer in the form of the question. Right, the question gave you denominators, so you should have denominators in the. I personally don't care, but as a general rule of thumb, you don't do it. So I don't care either way.
How come it's not two over?
What's the antiderivative of 1 over x cubed? It's negative 1 over 2x squared. Right, power rule. Add 1 to the power and you divide by the new power, right? 2/3 times a half is 1/3. So that's what happened to the 2/3. Just imagine how much longer that would have taken if I made you solve that system by hand. Which again is algebra. This is all algebra up until that very last step. Welcome to calculus. That's 95% algebra. Oh, and by the way, that was just linear factors. You should recall that when you factor a polynomial, it's a product of linear and irreducible quadratics. So what happens if we get an irreducible quadratic in the denominator? So glad you asked. We're going to look at that right now. First step is always the same. Is the rational function proper? No. Yes. What's the degree of the numerator? What's the degree of the denominator? Which is larger? 4. Proper. Yay. We don't have to do any kind of division. That's nice. And by the way, method of partial fractions can also be used in certain circumstances to avoid trig sub. We want to completely factor the denominator. How does the denominator factor?
X squared plus 2 times x squared plus 1.
To keep it in line with what I have in my notes, I'm just going to write it in that order, but it doesn't matter. Both of those are irreducible quadratic. The idea is still the same. Just go factor by factor. First factor, x squared plus 1. It appears only once. It will contribute ax plus b over x squared plus 1. X squared plus 2, irreducible quadratic, appears only once. It will contribute cx plus d over x squared plus 2. Again, you want them as improper fractions, which means the numerator is linear. So it has to be ax plus b.
So if instead of a single x squared plus 2, we had x squared plus 2 all squared,
Then you'd have a second term, just like you would with linear, yeah.
like ex.
So it'd be
plus
ex plus f over x squared plus 2 quantity squared.
f. Okay.
Right, so that's the same.
Next one. I don't know.
Has to be improper. Or it has to be proper, right? So if your denominator is quadratic, your numerator has to be linear. Right, so it could have an x term in the numerator. Doesn't mean it does. But again, that a could be 0 for all we know. Point is, we don't. That means if it was cubic, thankfully, you'll never have that case because a cubic will factor. Then your numerator would be quadratic. Right, to still be a proper fraction. Right, does that make sense? The idea is the same. We want to find A, B, C, and D. And we do it the same way. Clear out the denominators. Except now, you do have to FOIL. Again, unless you're really good at doing this in your head. And there's the FOIL for the first. And there's the FOIL for the second. Oh, and if you get like ax squared plus bx plus c to the 5th power, the denominator is irreducible. Have fun. Because that is a lot of algebra. That's why I quit and just let Mathematica do all the work for me. Group together like terms. X cubed. A plus C. X squared. B plus D. X. 2A plus C. And then our constant 2B plus D. A plus C has to be 1. B plus D has to be 1. 2A plus C has to be 1. 2B plus D has to be 2.
So we see A makes no difference, so it has to be 0. And then C has to be 1.
So 1x cubed.
And then I guess we see B makes 1 difference, so B is 1 and D is 0.
And maybe so for the last one, or like. Original equation.
Well, D can't be 1.
I said D is 0, but B is 1.
You could argue that way. That's fine, as long as you get the right answer. We technically have 2 separate systems. We have 2 systems of 2 and 2 unknowns. Right, that makes this easier to do. A plus C equals 1, 2A plus C equals 1. That means A has to be 0 and C has to be 1. Right. Another way I can think about it is A equals 1 minus C and 2A equals 1 minus C. There's only one way that's possible, and that's for A to be 0, which means 1 minus C also has to be 0. It's a very similar argument with B plus D equals 1 and 2B plus D equals 2. Right? So D equals 1 minus B, D equals 2 minus 2B. There's only one way that's possible. D has to be 0. Which means 1 minus B has to be 0. So B is 1. That would not be possible. Because then you have 2 times 1 equals 1. Right, which doesn't make sense.
A plus C, then how did you get that they need to equal? I thought I understood it before.
Look on the left-hand side. Right, so compare the x cubes. On the right-hand side, you have A plus C, right? In front of the x cubed. What do you have in front of the x cubed on the left-hand side? Right, remember, this is all equals, right?
Yes.
So this,
Oh.
Oops.
Of course, the code.
uh-oh. Now my mouse is off. Oh dear.
Never mind, I got it.
Right, it won't let me highlight. I'm gonna have to restart this. But that's what you do, right? So that has to equal 1. Oh, I didn't write out the integral before. Oh, I'm gonna have to rewrite it. That's annoying. A is 0. B is 1. That just becomes 1 over x squared plus 1. B is 1, or I'm sorry, C is 1, D is 0. It gives us x over x squared plus 2. There's the decomposition. What's the first antiderivative? So what is the antiderivative of 1 over x squared plus 1? Because the derivative of x squared plus 1 is 2x. You don't have a 2x dx in there. So you can't do that. Another way of asking that. What function has derivative 1 over x squared plus 1? So the derivative of what function is 1 over x squared plus 1?
One of the trig inverses.
Which one?
If I had to guess, tangent inverse, so I'm not sure.
How confident are you?
I'd say 75%, but only after you turn it
All right, so let's say we're in Vegas.
back.
Except instead of money, it's going to be your grade.
I mean,
Out of 100 points,
confident, so.
how much would you wager? I can go in and change that. So what would you wager? It's always a good way to see how confident someone is.
I disagree with that.
Putting your grade on the line, that quickly tells you how confident you are. Maybe not as much as, saying you're in a dark alleyway and someone comes up to you with a knife and says they're going to shank you if you don't know the answer. Guess it's a really good way of determining how confident you are.
I mean, I try to take the derivative now, but sounds a bit hard.
That means you're not confident, which is a shame.
Is it?
That's what he said. So I was asking how confident is he in that? It is the inverse tangent. So when you do partial fraction decomposition with irreducible quadratics, you may wind up with inverse trig functions. Or worse yet, may have to do trig sub. Like if that was 1 over x squared minus 1, that's trig sub. Of course, if it was x squared minus 1, that would reduce to what? X plus 1 times x minus 1. So you could avoid that. What about that second term? X over x squared plus 2.
This one's the natural log of the absolute value of x squared plus 2 all over 2.
That's a u sub. let u be x squared plus 2. Derivative of that's 2x. We don't have a 2, but we do have an x, so we multiply the result by 1/2. There's your antiderivative. No, it's not.
The one half come from. Be up there yelling thing.
U sub.
That only thing makes sense.
U sub.
When did that happen?
Right here. What's the derivative of x squared plus 2? Right, 2x. There's your x dx. What are you missing? A 2, right? So you multiply by 2, and then multiply the result by 1/2.
Did you really do U sub, or did you just quote that the natural log of x squared plus 2 with absolute values, I guess, would work out right, and then so it did?
Well, I did it in my head, but it is U sub. That's the technique. Right, so if you're unfamiliar with U sub, you may want to go back and review the final lessons of Calc 1, because that's when it's covered. It's one of the last things you do in Calc 1, actually. I think for us, it was what, the second to last? I think we did fundamental theorem last. This is where we weed out the weak. This problem right here, has a lot of algebra. First thing you want to do, is it proper? It is. Denominator is fully factored. Has a single irreducible factor of x squared plus 2 that is repeated 3 times. So there is the decomposition. Not rewriting that, so.
Something irreducible in the denominator, can we just assume it's like ax plus b dx?
Well, it depends on how many times it's repeated. But irreducible quadratic numerator will always be of the form ax plus b. It'll always be linear.
What an irreducible cubic.
There's no such thing.
Is there any other higher irreducible?
No.
If there were, would it be?
Well,
Or if you just decide you didn't want to reduce it?
then
be-
it wouldn't be method of partial fractions. In theory, yes, it'd be 1 degree less in the numerator, but you never have to worry about that. Every polynomial can be factored as a product of linears and irreducible quadratics. That's part of the fundamental theorem of algebra. Because the denominator is quadratic. So the numerator has to be degree less than 1 less than that. Now, again, it could turn out that some of these are going to be 0, right? So maybe it's not. So maybe there won't be an x term. But there could be. Right? So we have to clear out fractions. The fact that it's only a single term is really nice. Right, you should be able to see how tedious this process can be.
For the ax plus b times x squared plus 2 squared, why aren't we also multiplying it by x squared plus 2 cubed?
Well, we did multiply by x squared plus 2 cubed. Right, this whole thing is being multiplied by x squared plus 2 cubed. But what's x cubed over x? That's why it's only a square. Right, what we're doing is we're multiplying both sides by the denominator. By this denominator. Right, so we're only multiplying by x squared plus 2 cubed.
Oh, because last time they had different.
Right. It was a product, right? So last time we were multiplying by a product. Here it's only a single term in the denominator that happens to be cubed. Right, does that make sense?
Yeah.
So expand out x squared plus 2 all squared. That's what you get. Now foiling. Oh boy. Okay. Ax to the 5th plus bx to the 4th plus 4ax cubed plus 4bx squared plus 4ax plus 4b. That's just the first term.
Rather than foiling, look at like just search for every term that'll give you next to the fifth,
Good.
etc.
That's what I said. If you're really good at doing it in your head, then that's what I would do. But you have to be careful because if you miss a term, it screws everything up. So if you're not confident, I would recommend just, writing it all out. Dx cubed plus dx squared plus 2cx plus 2d, then plus ex plus f. Group together like terms. We only have one x to the fifth. We only have one x to the fourth too, by the way. That's nice. For x cubed, we have 4a plus c, x squared is 4b plus d. X for a plus 2c plus e. And then the constant is 2b plus 2d plus f. At the outset, this looked hideous. Now that all the terms are grouped together, this system is actually a very nice system. A has to be 1. Where did I get 2 from? I have no idea. Yeah, that's a 4b. A has to be 1. B has to be -1. Right away, we know 2 of the values. That's what makes this system really nice. For a plus c has to be 4. For b plus d has to be -4. For a plus 2c plus e has to be 8, right? And then 4b plus 2d plus f has to be -4. This system is really easy to solve. You know A, you know B. Because you know A, you now know C from the third equation. You also know D from the fourth equation. A has to be 1, B is -1, right? That was given. That means C has to be 0 and D has to be 0, which means E has to be 4 and F has to be 0. First term would be x minus 1 over x squared plus 2. Write it as 2 fractions. C and D are both 0. That means that that second term doesn't exist. E is 4, F is 0. And you count your lucky stars that it was E that was 4 and not F. Because if it was F, that last term would be 4 over x squared minus 2 cubed, which is trig sub. The fact that it's 4x makes it U sub. And then it's just a matter of evaluating the antiderivatives. So you get a half log absolute of x squared plus 2 minus 1 over root 2 inverse tangent x over root 2 minus 1 over x squared plus 2 squared plus c. Questions on partial fraction decomposition?
That's how we go. 4x, so we x squared plus 2 to 5 cube.
It's u sub and then power rule, yes.